So you are 100% of my audience, in addition to my son, who already lives with me. So it's your decision. I will respect your decision because you respected me and came in time. Whether you want to proceed with the lecture or not. Today lecture is very important and it's fundamental for I don't say for the rest, but for a lot of maybe 40% of Java depends on understanding this lecture well. Without it, you don't understand well what you are actually writing. With it, it will make a big difference. So I respect you. You came in time. So you make a decision whether you want to go ahead today or cancel it today. You are 100% of the audience.
Right. Well, if it really is that important, then I'd at least like to learn a little bit of it.
Okay. So you want to start right now?
Yes.
Okay. Okay. Share. Share screen. Share. Okay, do you see my screen now?
Yes, I'm able to see the screen.
Okay. Last time we talked about the Java comparison operators, equals to, not equals, greater than, less than, greater than or equal, less than or equal. I will start from here. Last time there was a problem with my environments, but that's one point. The second point is that I wanted to add some basic information here. So from here is a new lecture. Java comparison operators produce either produce an expression called the logical expression, which is either which evaluates to either true or false. These logical expressions are also called Boolean expressions. This is named after Boolean algebra, which is created by Georges Boole, the French scientist in, I think, 18th or 19th century, I'm not sure, who made um, a parallel algebra to the current algebra, the algebra we know, known as a Boolean algebra, that depends on evaluating facts or evaluating actual expressions, like as true and false, and made some a whole set of logic algebra on it. We will definitely talk about it later. But anyway, the facts in expression in the Boolean algebra are represented as true and false, and they are represented as 0 and 1. Actually, 1 and 0. Let's we can modify the word, the names to be consistent. So either we say true and false, you say this 1 and 2, 1 and 0. So 1 means true and 0 means false, and there are several operations can be done upon them. So one of the operations, most important operations are AND, OR, XOR, and NOT. These are the main operations that can be done on the logical expressions or the Boolean expressions. What are they do? What are they? And what do they do? Simply, they operate on logical expressions to either modify them or combine them. I will repeat what I said last lecture quickly. Suppose that you have you want to take a decision based on two criteria. Like I want to quit my job to a new job. So if the pay is good, is better, or the environment is better, I will move. If the pay is better or the environment is better, I will move. That means if the pay is better, I will move. If the pay is better and the environment is not, I will move. If the environment is better but the pay is not, I will move. If both of them, I will move, but I will not move if both of them are better than are comparable to my current position, my current job. This is an operator called OR operator. This is the OR operator. Okay, and it combines two logical operands or Boolean operands, and it produces or returns true in case any of them, at least one of them at least, is true. There's another operator called and the operator AND produces true only in case both of the operands are true. Like if tomorrow I'm free and the weather is fine, we will go for picnic. So if we will go for picnic, if and only if both conditions occur. I'm free and the weather is nice. The third operator is called the XOR, exclusive OR. This is similar to OR, but it means the expression will be true only in case one of the operands is true. So suppose that we have to select from different different candidates in the elections. I want no, this is not a good idea. Okay, I don't have an example in my head right now. I forgot there was one, but I forgot it. But anyway, it means exclusive condition where one only is true, the other is false. So the first condition is true and the other is false, or the first is false and the other is true. If both of them are true or both of them are false, the condition is not true. Ah, yes, I got the example. You remember the light bulb with the two-way key is called the door key. No, is it not or not? When you have two keys that both control a light bulb. The light bulb works if they are both in one side, either up or down, it will work. If they are suppose that if the left one is up, let me the laser pointer. If this is up and this is up, the light bulb will light. If this is down and this is down, the bulb will light. If one is up and if the first one is up and second is down, it will not light. If the first one is down and the second is up, it will not light. This is an example of exclusive OR, where two conditions, two similar conditions produce a value, and two other different conditions produce another value. Okay. The last one is the logical NOT. And NOT simply reverses the operand. So you can say if I am not facing the target, the robot is not facing the target, keep rotating until you find it. So facing is a function that reduces true if my value, if my deviation angle is between -5 and +5. If I'm not facing it, keep rotating. Okay. It simply gives the reverse of the operand. The reverse of true produces false, and false produces true. Okay, that was the last lecture, and I'm repeating. I just repeated it. Now, today's topic is very important, which is about variables and data types. This is very, very, very important topic. In Java, data is stored in one of two formats. Forget about those who tell you a lot of data types. There are two general data types, and this structure will make your mind understand how the things are arranged. So data is either a primitive data or a reference to an object. So either primitive or object, and if it's an object, then data is actually a reference to that object. And maybe 3 or 4 slides we'll talk about how this is produced in located in memory. Anyway, so a reference to an object is for complex data, and primitive is for single valued data. Okay, single valued data can be either Boolean, which we just mentioned in the previous 2 slides. Are you following?
Yeah.
Okay, can be Boolean, or can be integer, or can be floating point. Floating point is the computer, as I said earlier, is the computer science way of saying decimal or fraction values. So either Boolean, true or false, 0 or 1, integer, or floating point. So far so good?
Yeah.
Okay, nice. Now let's the fireworks start. Oh no, not yet. And the reference is for everything else, which is mainly for complex data. Now let's the firework starts. The space taken for the single valued data can be stored in memory in either 1 byte, 2 bytes, 4 bytes, or 8 bytes. If it's 1 byte, the data type is called byte. If it's 2 bytes, the data type is called short. If it's 4 bytes, data type is called int, which means integer. And if it's 8 bytes, the type is called long. So we have 1 byte and we have short, int, long. 1, 2, 4, 8. You can simply remember them this way. Byte, short, int, long.
Right.
So far so good?
Yep.
Okay. For the floating point, we have 2 types. One type which consumes or takes 4 bytes in memory. This is called float, short for floating point. As I said, this is a computer science way of saying decimal fraction. I didn't say decimal fraction. And double, which is short for double precision. So we have long precision, we have double precision. the double precision takes 8 bytes. So simply we can consider that int is comparable to float and long is comparable to double, but the two on the left hold integer values, and the two on the right hold decimal values or fractional values. Actually, they're not decimal; they are binary. Okay. So now we have 1 byte, 2 bytes, 4 bytes, 8 bytes, and we have 4 bytes, 8 bytes. There is another form of value that is integer as well, called char, short for character. And the character is one letter or one symbol. This symbol can be an alphabet like A, B, C, D, or capital A, capital B, capital C, capital D, or an emoji, or a brick that represents the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, no more, or the symbol of the plus sign, the symbol of the dollar sign. And here I'm talking about the symbol. So the symbol 0 is not the value 0. The symbol 9 is not the value 9. Okay, I'm talking about symbols. Symbol 9 or symbol A, okay, or symbol plus, or symbol capital A, etc. Okay, nice. Now we have two data types that both take 2 bytes in memory and both are whole integer values. Before I forget. So this character holds the number, the code that represent this symbol in the Unicode table. If you don't know what Unicode is, then don't bother. You know it later. Nice. Now we have two types, short and the char. Both of them are 2 bytes. Both of them hold integer values. So what is the difference? Why two data types? Because the character is the only unsigned type of all the numerical data types. So any other numerical data types have keep a bit, a portion of the byte for the sign value. But the character does not have a designated bit for the sign value. That means if we have a byte, which is 8 bits, as most of us know, there will be 1 plus, this is plus, 1 plus 7, same for the data, and 1 for the sign. This is plus. I want to write it plus so that nobody makes it. We have short, then we have 1. 2 bytes means 16 bit. So 1 plus 15 for the numbers. But for the case of the character, it's 16 bit. Okay?
Makes sense.
Nice. For the int and the float, we have 4 bytes. 4 bytes. This is 32 bits. 32 bits. The long have 64 bits. The difference between int and the float is that, and between long and double, is that these 64 or these 32 are dedicated for the values to the left of the decimal point, while for the case of float and double, it is more complicated. I'm going to describe how it looks right now, but it's a little more complicated. Okay,
Okay.
nice. And this slide is for demonstration only. Okay, so don't panic if you don't get everything in it. It's just for demonstration. But if you understand it, it will make your life much easier later. This is how different data variable flavors look like in memory. So if you have an integer, let's name it a of the type, so a variable of the, let's name it a and of the type int. This is how it looks in the memory. Binary, if the value is 5 int, this is how it looks in memory. First byte zeros, second byte zeros, third byte zeros, fourth byte contains the value 0000 0101. This 0101 stands for the value 5 in binary system. I'm not going to talk about binary system today, or maybe never. This is not a binary lecture, binary course. This is Java course. Floating point. For the floating point, 5 is written as 5.5.0, or as long as there is a dot, then this is a floating point. You can write only 5 dot or 5.0, both are the same. This is a binary value. This looks way different. We have here something called some component of the value we call the exponent, and we have the mantissa. So this is 5, but in this location, and this is the power. Let me use another color because these are all reds. Erase all blank slide and use highlighter. We have 0101. This is 5 in the binary in the binary in the integer format. This is 5 in the floating point format. Okay. Here we have 1 stands for the power. Okay. The character 5 is the binary value of the ASCII or the Unicode letters. Here we have the character 5, the character 5 takes the value of, where is 5, 5, 5, 5? 5 takes the value of 32 decimal, sorry, 52, which is 34 hexadecimal. No, 4 was 5. 5 is 53, which is 35 hexadecimal. Those who made the ASCII table, ASCII stands for American Standard Code for Information Interchange. It's another story I'll talk about later. Anyway, they were kind enough to make us some way relate this 5 to this 5. Okay, but it's more or less like a coincidence, but an intended coincidence. Okay, so anyways, what we care about here is that the character C, if it contains the symbol, not the value, the symbol 5, it has the value of 53 represented in hexadecimal as 35 hexadecimal. In the ASCII or the Unicode, actually, they are the same in the first 7 bits domain. And this is a value, how the value is represented. The value 35 in hexadecimal contains the value 5 from the symbol. So roughly we can some way convert from the symbol into the value or vice versa. So it's an intended coincidence. Okay. Now the string S, which so we say S1 because we have more strings, which contains the character 5. Suppose that you are asked about your robot number. So robot number is only 5, or maybe even more. Or asked about your address, home address. So you live in 5 Main Street. So 5 here is part of a string. The string that contains the 5 is an object. All of these are primitives. Okay, this is an object which contains 2 components. We'll talk about strings in the next slide. Not next slide, in a subsequent slide later. I just want to say that here it has 2 components. The first component is pointer to the value in the memory. The second component is the length of the string, and this pointer points to the place of memory which contains the character 5, which is this character. Another string contains can contain 555. It means there is an object in the memory that has a length of 3, 1, 2, 3 characters, and start somewhere. It's possible, coincidentally as well, that this 5 can be a part of 555. Okay, we'll talk about strings someday later in this course, but I just want you to see the how the data is represented in the memory. These are primitives. These are objects, and this character is a primitive, which is part of this object or that object. So far, so good. If you don't understand, I'm fine, but I would be happy if you understand everything.
Mm.
How
Well,
much percent did you get? 50%?
Yeah, I think I sort of understand it. It's a little bit overwhelming, but I think I get the basic picture, I think.
Okay. Do you understand? Do you know first what is a bit and what's a byte?
Yeah. 8 bits is 1 byte from what I'm
Yes.
getting.
Yeah, that's right. In French they call it octet, which is more representative naming.
Hmm.
Okay, so we have here 4 bytes. Everyone is 8 bits. We have also 4 bytes. Everyone is 4 bits. So this is 5 in integer format. This is 5 in decimal format. This is 5 in symbol 5, which is a character. How it is represented, represents here. And this character is used as a building block in the string, whether it contains 1 or more characters.
Okay. I think I got it.
Okay. This slide is not important, but it will make you understand what you see and be able to convert things later.
I see.
Nice. Now, this slide is very important and you must know it. Everybody must know it. Java operations are performed on 4 bytes at least.
Hmm.
On how much? How long?
4 bytes.
4 bytes at least. Okay?
Right.
So if you have a byte or short or character, and you want to do any operation on them, the byte is represented in 1 byte only. The short and character are represented on 2 bytes only. The int and float are represented in 4 bytes. So if you want to do any operation on a byte or a short, this operation must be promoted first into 4 bytes or more for the case of the operation to be performed. They are promoted. They are promoted. This is called promotion. From 1 byte or 2 bytes into 4 bytes or maybe 8 bytes. And if you want to assign the value of an int to a short, this operation is called casting. Actually, the promotion is implicit casting. Any conversion is called casting. Okay. So if you want to assign the value of a long or int to int or int to short or whatever, it must be done explicitly and it's called casting. The same from double to float and from to come back later. Okay. Let's leave the presentation now and do this on the compiler to see how it works.
Okay.
Wait. Okay, do you see my IntelliJ?
No, I don't see the IntelliJ.
So share fire screen, share. You see the J now?
Yes, I see it now.
Okay. Sure that works, not like last time. Last time it needed to restart. That's why it didn't work.
Hmm. I see.
Nice. Okay, let's. Do you want to work on a project, a class file, uh, or on the J shell?
I don't think I have the J shell.
By the way, I want you to start doing these things yourself.
Okay. Yeah,
Let's
I'm
do this.
trying to open it.
مريم I'm in a lecture. أنا في نفس الوقت مش هينفع تتكلمي جنبي.
Okay. Do I just open a new project
Uh,
there, or is there something else I need to do?
can I see your screen?
Okay. Let me just share.
Let me stop sharing first.
Okay, let me see.
Okay, while you open your IDE and start a new project, shall I continue what I was doing? Let's declare int a equals 3, int b equals 4. Okay, int c equals 7. Is there anything wrong?
No, I'm just trying to enable Zoom to be able to share.
Wait. Are you able now? Let me stop sharing. Now you start your share.
Okay. Bismillah. Ah, it still won't work. Uh, it just says whenever I try to share, it just says open system settings.
Mm.
And then I do that, I enable Zoom to share, but then it just brings me to a file, and there are just a whole
Are
bunch of
you on
files.
Mac?
On Mac, yes, I am.
Mac is silly in this pipe, but you have to give it the the permission, and then I think you need to close and start it again, something like that.
Hmm, okay, let's.
Shall I wait?
Um, yeah, I'm trying to. Yeah, so you're saying I should have to restart my computer, or
No, restart your Zoom only.
oh, only.
I'll be waiting for you.
Okay, here I am back.
Come back.
Let's see. It's still not working.
Okay, let me.
But hang on a minute, I think I might have it. Why am I on?
Interrupting second.
Okay, focus on with me now, and we fix that later.
This book is
Uh,
called
okay. Hang on. 1 minute, be right back. It says it is for me to leave the meeting and join again, so I'm gonna do that. Be right.
Now please
Okay.
start. My favorite. Who was laughing for the
Oh, it's working.
Okay. Nice.
Okay, so I have this. What do I do from here?
Nothing from here. Click on projects
Projects.
and new project or open.
Uh,
Either select untitled and open it.
okay. And
What do you do? I didn't see.
can you see it?
No.
Okay.
Maybe you need to share, reshare, or share the whole screen.
Yeah, okay. I'll just share the whole screen.
to get the soft.
Okay.
Okay, that's great.
So, yeah, this is what I have.
Okay. You can delete everything in the main function to make it little less cluttered.
Okay. Do I just
On the main function, leave the class definition and yeah, from line 7, from line 5 to line
okay. Hang on, my computer's doing something weird.
line 5 to line, I don't see,
Uh,
to line 12. We don't need any of them. No,
okay, line
13
5 to 12.
to 13 to
Right.
you can delete all of this from line from 5 to 13.
Right.
What are you doing?
I don't know. Is this not the deleting?
This is how to add a breakpoint, which is not what we're doing now.
Oh,
Just click in the workspace.
in, and then I just
Yes.
highlight delete. Okay. Why does it keep breakpointing?
You did it. Yeah. I thought that just do it.
Fine. That's fine.
Okay.
Nice. Now within the main screen, main function, start typing int a equals 3.
Int.
Please indent your writing.
Uh, uh,
No.
the, so I just indent like, oh, hang on. Like,
Now tab. Click tab.
Yeah, I'm clicking the tab, it's not doing anything.
Why?
Oh,
Another tab? Yes, that's fine.
there we go.
Yes. Okay, now write int a equals 3.
Int a a
Okay.
equal. Oops, that's the plus sign equals 3, like this.
Yes, semicolon,
Hmm.
semicolon. This
Semicolon.
is a this is a sentence,
Is that
Okay.
statement. Okay, nice.
Wait,
Enter.
right statement or
then?
Semicolon is the end of a statement. Enter.
oh, I see.
Now you declare the variable called a with a value of the type 3 and the values type integer and the value 3. Now int b equals say 4.
B or
Yes.
yeah.
Okay. Uh, int
Okay.
c equals, let's say a and a plus b. Then how much will c hold?
That means C will be 7.
Okay. Now click and now press enter. We want to print them. So write s out,
Say again.
s out or system dot out.
S out.
S no, not space, not with space. It's one
Just
word.
S out. Like this.
Yes. Control space now. Yes. Click
Oh,
enter. Select this one.
okay.
This will write system dot out dot println.
One. No.
مريم انا في محاضره لو سمحتي ما تعمليش صوت. What is a carrot?
The carrot. I have 2 carrots.
Okay, put it within the parentheses of the println.
Okay, like this.
Just write C, so it will print C.
Enter.
Fine, that's fine. Okay, now let's run this. No. I didn't say enter.
Okay.
Control Z. Now run.
Run. Yeah.
You know where to run?
Uh, uh, where is the run button? Oh, I see it.
The green arrow.
Yeah. Uh,
No, don't use this.
which one do you use? This one
Use the one above.
above.
No, wait. Leave it now. Let's leave it running. Compiling. Do you
Okay.
see
Here's a map.
at the title bar?
Okay.
It's still first time to run an application. You see main, the title bar,
Yeah.
and
So,
a rotating wheel.
yeah, I see the
This was
rotating.
this was an arrow before. It's still rotating because it's still compiling. This is the first time to run your Java environment.
Yeah. That's not exactly the fastest computer, so the loading takes a while usually.
First time we need first time to run will take some time. Actually,
Okay.
it's taking time in indexing, not in running. You can cancel this indexing to make it a little faster.
Uh,
You see indexing below. Yes, now leave it compile. Yes, it's compiling now.
okay, nice.
One error. What is the error?
Uh, I don't know.
Please run again, but run from
This
yes
green
from
arrow.
this. Yes.
And it says running.
build running, build output, executing pre-compiled tasks.
Mm.
What's wrong?
Yeah.
Process termination. Nice dash n 10 Java. I don't see the rest.
Uh, yeah, let me just move you.
Okay, I can't wait much for on this.
Okay, yeah, I understand.
I either ask your parents to help you with this, or let's do it together
Okay.
on individual basis.
Okay. Yeah, let's do that.
I will continue on my screen.
Okay, so I'll just stop sharing.
Yes, please. Okay. So int A equals 3, int B equals 4, int C equals 7. Are you following?
Yeah.
This out. A. Another one B. One C. Okay, let's run this. Building. Started to take a long time like last time. A long time like the last
Yeah.
instance. This is not good. What is happening? Before success getting the dependency information, parsing Java. This is no good.
Yeah.
Let me terminate and run again. It started to hang. Are you still in the meeting?
I'm not seeing anything. It just says you stopped sharing, and all I see is just me, you, Mohammed, and brother Asif.
share, screen, share. I'm waiting for IntelliJ to start. Maybe you can use the J shell. Maybe faster. No, it already started already. Fine. We are here. Let's run this. Okay. 3, 4, 7. Fine.
Right.
Okay. Let's repeat the same thing, but with short. Short x equals 3. Fine.
Hmm.
Short y equals 4. Oh, no, okay. Short z equals 7. Fine.
Right.
This out. X and y and z and run. Okay, 3, 4, 7, 3, 4, 7.
Oh, nice.
Okay. Now let's add these two lines. Int d equals a plus b, which is 11 as well.
Hmm.
And print d. Okay,
Mhm.
this two lines. Any problem?
No problems.
3, 4, 7, 7. 3, 4, 7.
Nice.
Let's do the same with the short. Let's add w equals x plus y. Now, what do you see here?
So it is being highlighted by the red, which implies that something's
Yes.
incorrect.
Let's try to run and see what will happen.
Oh,
Runtime compile time exception, Java, incompatible types, possible lossy conversion from int to short. Where did the int come from?
right, because
The x is short and the y is short. Where did the int come from? The int came from here.
Oh yeah, right.
Because Java starts any operation on at least 4 bytes. So even if you have a short, the short, when it is just as it is, it alone, it is short. But when you use it in an operation like a plus b, this this operation cannot be done on anything less than 4. So both of a and b are promoted into integers. It will be integer plus integer, which will produce integer. Okay, these two are promoted into int. A, it was short, promoted to int. B was short, promoted to int, because the plus cannot work on anything less than int. So int plus int is stored in int. Now, if you want to take it back to store it in short, we cannot. If we make this int, it will be fine. It will not complain. Get it?
Right.
Now let's print this out. W. And run. Three, 4, 7, 7, 3, 4, 7, 7. Okay.
Right.
So this is one way. The other way is to, if you want to keep W as short, is to return last expression short to short. Yes. Is to return this expression into short. Casting is done using this format. You write short within between these parentheses, but you need to select the whole expression, because if you don't select the whole expression, it will understand it as short x plus y, which did not do what we want. We want to make it short x for the result of x plus y. This should work. And now W is in the form of in the format of a short, 2 bytes, and it will be fine. It will not complain. Okay, let's make it two ways. We have short W1 and the int W2. Okay. So this way works and this way works. The difference is that in the output is now either a short, now 3, 4, 7, 7, 7. The difference is that the W1 is short, the W2 is what? Int.
W2, yes.
Okay.
Right.
Why I was showing all of this, because I wanted you to understand that any operation that's done on a smaller operands, smaller size operands, other than smaller than 4, will definitely be promoted to at least 4, because I cannot do any operation except on when it is on two equivalent size operands, at least 4. Okay.
Right. Got it.
Nice. Now let me ask you, if I have int plus int, what is the output going to be?
Most likely long.
Int plus int
Int plus int.
will be int.
Oh, it
Okay.
will? Oh, okay.
Short plus int, will it be?
It will also be int, I think.
Right. Short plus short will be in?
It will be int as well, right?
Yes. Byte plus short will be in?
It will be short or
Int, because at least 4
Yeah.
bytes.
Oh, I see.
Equivalent and at least 4. That's
I
why
see.
when it was short and short, it was promoted to int.
Ah,
Okay.
got
Car
it.
and short
That will also be int?
will also be int. That's fine. Okay. Int and long.
Int and long, will that also be int or will that
No,
be?
will be long because
Uh,
we cannot do the sum operation, the operation
right,
on
you can't take them.
on unequivalent types. So the
Right.
int will be promoted into long.
Right.
Okay.
Okay.
Okay. Byte plus long or byte times long.
Will that be long as well?
That's right. Okay.
Hmm.
Now going to this column, float plus float.
Float plus float. Oh, will that still be float or int?
Float.
Right.
Float and int are both equal in size. Okay. Now let's make it this way. This way. I have the value of 2 plus 1.5. This is 2. That 2. This is 2.
Right. Yeah.
And 2 plus 1. How much is the output in both cases?
Well, the first one would be 3.5 and the second one would just be 3.
Fine. So 3.5, can it be stored in integer type or must be stored in floating point type?
I think it must be floating because it's a
That's
decimal.
correct. That's correct. So that means anything that goes into this column will not return back. I mean, not return back from itself.
Right.
So if you have int plus int, it will be int. If you have int plus float, it will be float.
Right.
If you have float plus float, it will be float. This is easy.
Hmm.
If you have
Right.
float plus double, it will be
Double.
double. Int plus double,
Int plus double, that'll be double too, right?
float plus long,
Float plus long, that'll be float.
no.
No,
It will be
it'll be long.
no,
What will it be then?
will be double because the long is 8 bytes and the float is floating point. So you
Oh, yeah.
promote, so you promote in both directions.
I see.
Float and long will be, the float will be promoted into double and it will be double plus long. So we'll go to this direction. So the output will be double. Did you get it?
Yeah, I get it.
That's why this lecture is very important.
Yeah.
Otherwise, when you do the calculations later, you will fall in a lot of either uh, miscalculations or you will pull your hairs until you are bald like me, or you will at least do the calculation very slowly because there will be a lot of unnecessary conversions.
Yeah. Right.
Okay,
Okay.
this is the most important slide for today. That's fine. I think we will understand all of them. Integer types have hold integer values, and these are common operators: plus, minus, times, multiplication, division, and modulus. And these are sample literal values. Double calculates floating point, called floating point operations, and there is no modulus in the double because the double makes make fraction, so there's no reminder. So we have values like 3.14, the pi, and anything else. There's also a value, which means 6.022 times e to the power times 10 to the power 23. I don't know whether you are familiar with this scientific notation or not.
Uh,
So Google can be written as 1 e 100. This is Google. Okay, which means 1 times 10 to the power 100. Boolean values, most common operations are the and, the or, and the not operations. There's also XOR, but we don't care about it here now. And these are only two literal values, small and true and false, in Python, in Java at least. Characters contains values like a, 1, these are symbols. It's important here to notice that the character literal is enclosed between between a pair of single quotes. The string is enclosed between a pair of double quotes. On the keyboard, they are on the same key. The one to the right, two characters to the right of the L character. One with shift and one without shift. In other languages, there is no distinction between char and the string, so either of them can be used. Like Python. Python doesn't have specific dedicated type for char. So you can use either single quote or double quote. Either a pair of single quote or a pair of double quote. Java distincts. So we have pair of single quotes for character, pair of double quotes for string. And there is only one operator that works on the string, which is the plus. Actually, there is no operator in the Java on the string. This is just something called operator overloading to do the concatenation process, which we will talk about when we talk about the string later, inshallah. This is one big topic has been covered already. Before we go, I just need to talk about the slide. Java basic input and output operations are done in 3 streams: the input stream, the output stream, and the error stream. What are the streams? Streams are pipes, like pipes or pathways to send or receive characters from the Java process to another process or to the user. The default input stream is simply reconnected to the keyboard. So when you click Aiden or Amr or Muhammad, Mohammed, these things, you are sending characters to the input stream. When you write something using system.out.println, and this is what we did here, this out is actually the streams out, the default output stream related to the system, and it connects directly to the console. There is another stream similar to the out stream called the error stream. Which is dedicated to the error messages. Usually you'll see it written in red. Yeah, usually. Okay. The default is that both the error stream and the output stream or both go to the screen or to the console, but this is not always the case. And you can redirect any of the three streams, the input, the output, and the error, to or from files or screens or console or whatever. There's something advanced, but you need to understand what.
اسكتي
اقفل الصوت. Do you want to, do you want to ask something
سؤال
in English?
لو if you printed to the in stream, is it like simulating keystrokes?
You don't print to the input stream. You take from the input stream. But yes, this if you can redirect the input stream to take from a file, and this exactly is a simulation. Simulates keystrokes.
شكرا.
Okay, nice.
Hmm.
Later, inshallah, we'll be taking input from the user through the system.in. But now I need you to understand that system.out is how you print the characters to the stream or a file to the stream, which is going to by default to the screen or maybe to a file, anything else, a printer or not anything else. And error is similar but dedicated usually for errors and in for input from the user. This will be the end of this lecture. And it was a big one. We did the project hello world already. Cheat sheets, if you want, you can see them. And it's the end of the lecture. We still have for 15 minutes until Giovanni's lecture, inshallah. Any questions? Muhammad asked the question. Any other questions by anyone?
No, but thank you very much for doing this, even though it was mostly just me and then Brother Asif. I feel like I learned a lot. Thank you.
You are welcome. As you respected me and came in your time, I have to respect you and give you your lecture.
Thank you. I have to go now. Thank you again. Assalamu alaikum.
Before we leave, if you want, we can terminate the recording and I sit with you to make sure that your environment is working fine, if you would like. Let's first terminate, stop the sharing and terminate because it stops the recording.